The air in the small, cluttered office was thick with the smell of stale coffee and ozone, a silent testament to the impossible hours spent chasing a ghost. Outside, the city slept, unaware that within these four walls, a man had just touched the face of the future, only to vanish into the past. This is the story of Dr. Elias Thorne, a man who solved the equation that should not exist, and the silence that followed, a silence that cost humanity decades of progress. What if the greatest discovery of our time was not a revelation, but an absence? What if the key to unlocking the universe was simply lost, not to fire or flood, but to a single, inexplicable moment of disappearance? The question is not what he found, but what he took with him. The mystery of his vanishing act is a far more compelling puzzle than the mathematics he left behind. The year was 1968. The world was a canvas of sharp contrasts, a battleground of ideologies and a crucible of scientific ambition. The space race was in full, frantic swing, a desperate sprint for the stars, and the shadow of the Cold War stretched long across every laboratory and university campus. It was an era defined by a relentless need for advantage, a time when a single mathematical breakthrough could shift the balance of global power forever. Dr. Elias Thorne was a quiet, unassuming figure at the prestigious Institute for Advanced Study, a man whose mind moved at a frequency few could comprehend. He was an anomaly even among the geniuses, a mathematician who spoke the language of physics with a fluency that bordered on the mystical. His obsession was the Thorne paradox equation, a theoretical construct that had tormented the brightest minds for half a century. It was a formula that promised to unify the seemingly disparate forces of gravity and electromagnetism, a grand theory of everything that would not only explain the universe but allow its fundamental mechanisms to be manipulated. Specifically, it dealt with the concept of localized spacetime compression, a mathematical framework for what the science fiction writers called warp field mechanics, a method for generating a stable, controllable bubble of distorted spacetime. Most dismissed it as a beautiful, but ultimately flawed, piece of mathematical poetry, a dead end that violated the known laws of thermodynamics and causality. But Thorne saw the flicker of truth in the darkness. He lived on black coffee and the relentless pursuit of a number that would make the impossible, possible. He often worked for 72 hours straight, fueled by nothing but pure intellectual fire and the haunting knowledge that the answer was within reach. The pressure was immense, not just from the academic community, which saw him as a brilliant eccentric whose work was becoming increasingly esoteric, but from the quiet, suited men who occasionally visited his office. These were not academics. They were the silent architects of global strategy, men who understood the military implications of unlimited, clean energy, instantaneous communication across vast distances, and the ability to project power anywhere on the globe in a matter of minutes. They saw a weapon, a shield, a new world order. Thorne saw only the terrifying, yet sublime, elegance of the cosmos laid bare. He knew the moment he solved it, the world would change, but he could not have predicted the way it would change him. The weight of that knowledge, the sheer, unadulterated power of the truth, was a burden no single man should have to bear. The moment of the breakthrough was not a sudden flash of light, but a slow, creeping certainty, a feeling of the universe finally exhaling. It happened on a Tuesday, late in October. Thorne had been working on a seemingly trivial boundary condition, a small, almost negligible variable that every previous attempt had discarded as noise. It was a constant related to the spin of a specific subatomic particle, a detail so minute that its inclusion seemed absurd. He realized that the variable was not negligible at all, but the linchpin, the single point of failure in all prior calculations. It was a subtle asymmetry in the vacuum energy, a constant that only became relevant at the extreme limits of the equation, the point where the math described a physical reality. He scribbled the final sequence of symbols onto a large blackboard, his chalk scratching a frantic, triumphant sound in the dead quiet of the night. The equation balanced. The paradox resolved. The solution was an integer, a number so simple, so pure, that it felt like a cosmic joke, a punchline delivered by the universe itself. He had done it. He held in his hands the blueprint for a technology decades ahead of its time, a technology that could have rendered fossil fuels obsolete overnight, a technology that could have ended the Cold War not with a bang, but with a sudden, overwhelming abundance. The implications were immediate and terrifying: controlled fusion, gravity manipulation, and travel to the nearest star system within a human lifetime. He stared at the board, his chest heaving, the weight of the future suddenly resting on his shoulders. The air in the room seemed to vibrate with the sheer potential of the discovery, a silent, powerful hum that only he could perceive. He knew instantly that this knowledge was too dangerous, too profound to be simply published in a journal. The world was not ready for the Thorne solution. He reached for his briefcase, not to file the papers, but to secure them, to hide them away until he could decide how to introduce this world-shattering truth. A small, almost imperceptible detail changed everything. As he gathered his notes, the telephone on his desk rang, a jarring, mechanical sound in the silence. It was an old, black rotary phone, the kind that only rang when someone truly important, or truly desperate, was on the line. He hesitated, his hand hovering over the receiver, his eyes darting between the phone and the triumphant proof on the blackboard. He looked back at the board, then at the phone. It rang a second time, a demand, not a request, a sound that seemed to cut through the very fabric of his concentration. He picked it up. The conversation was brief, whispered, and utterly untraceable, a voice from a place he did not recognize, speaking words he would never repeat, a warning or perhaps a final instruction. When he hung up, his face was pale, his eyes wide with a mixture of fear and resolve, a man who had seen too much, a man who had been given a choice he never wanted to make. He did not erase the board. He did not leave a note. He simply walked out of his office, leaving the solved equation for the world to find, but taking the key to its understanding with him. He vanished into the cold October night, leaving behind only the ghost of a future that might have been, a future that was mathematically proven but physically denied. The next morning, the discovery of the solved equation was immediate, but the discovery of Thorne's absence was a slow, dawning horror. His secretary found the office door ajar, the blackboard covered in the triumphant, final proof. The scientific community erupted. They had the answer, or so they thought. The world's greatest physicists descended upon the institute, treating the office like a sacred, yet crime-ridden, scene. They photographed the board, analyzed the chalk dust, and argued over every symbol. But the solution, the integer that made the equation work, was meaningless without Thorne's accompanying notes, his explanation of the boundary condition, the context that transformed a sequence of symbols into a working model. The number itself was simple, a prime number in the low hundreds, but its significance was entirely dependent on the physical context Thorne had assigned to it, the precise experimental setup required to observe the effect. They had the final answer to a complex riddle, but they had lost the riddle itself. The search for Thorne was immediate and global. Governments, desperate for the technological advantage, mobilized intelligence agencies. They scoured the country, interviewed his few colleagues, analyzed his bank records, but found nothing. Thorne had simply ceased to be, a mathematical singularity in the fabric of history. The failed experiment was not the equation itself, but the frantic, decade-long attempt to reverse-engineer his final thoughts. Scientists could confirm the equation was correct, mathematically sound, but they could not bridge the conceptual gap that Thorne had crossed. They had the map, but the legend was missing, and without it, the map was just a meaningless pattern of lines. The world's most powerful supercomputers were dedicated to the task, running simulations for years, trying to brute force the missing context, but the sheer number of possibilities was astronomical, a number that would take longer than the age of the universe to fully explore. Conspiracy theories flourished. Was he abducted by a rival power? Did he go into hiding, fearing the consequences of his own discovery? Or did the knowledge itself, the sheer, terrifying simplicity of the universe's mechanism, drive him to a self-imposed exile, a final, desperate act of self-preservation? The mystery became a legend, the missing mathematician a ghost haunting the halls of theoretical physics, a constant, frustrating reminder of the knowledge just out of reach. The irony is that the solution to the universe's greatest mystery was staring them in the face, yet remained utterly incomprehensible. The true magnitude of Thorn's disappearance is not measured in the loss of one man, but in the stagnation of an entire technological era. The Thorn solution, had it been fully revealed, would have accelerated human development by at least 50 years. Imagine a world where the energy crisis never happened, where global communication was instantaneous and secure through quantum entanglement, where space travel was a matter of days, not months, powered by zero-point energy harvesting. The implications for medicine, for material science, for the very structure of human society were staggering. The ability to manipulate gravity would have revolutionized construction, transportation, and even warfare. Instead, the world was left with a tantalizing, frustrating fragment of genius. The decades that followed were spent chasing false leads, pouring billions into research that was fundamentally flawed because it lacked that single, crucial piece of context. The failed experiment of the 20th century was the inability of the collective human mind to grasp what one man had seen. We built bigger particle accelerators, more powerful supercomputers, we even landed on the moon, but we were always one step behind the ghost of Elias Thorn. His absence became a historical monument to the danger of knowledge without wisdom, a permanent asterisk next to the chapter on human progress. Every time a new energy source is debated, every time a new limit in physics is reached, the shadow of the Thorn paradox equation looms large, a constant reminder of the future we were promised, and the price we paid for its loss. The lost technology was not just a machine or a formula, it was a paradigm shift, a different way of seeing reality that we were simply not allowed to inherit. The world we live in is the diminished version, the one where the great leap forward was aborted by a single, whispered phone call. The tragedy is that the solution is still there, on that faded photograph of a blackboard, waiting for another mind to make the same conceptual leap, a leap that has yet to happen. We live in the world that Thorn left behind, a world still grappling with the problems he had already solved. Was his disappearance an act of cowardice, or the ultimate act of preservation? Did he save us from ourselves, preventing a technology that could have been weaponized into oblivion, a power too great for the fragile geopolitical landscape of the Cold War? Or did he condemn us to a slower, more difficult path, simply because he could not trust humanity with the truth? The answer remains locked away, perhaps in a dusty journal in a forgotten corner of the world, or perhaps only in the silence of the cosmos. The smallest action, a single phone call, a moment of hesitation, can create a ripple that changes the course of history forever. Think about that the next time you look up at the stars, knowing that the key to reaching them was once written on a blackboard, only to be erased by the wind of a single, fateful decision. We are still living in the shadow of that lost future, a future that was solved, but never delivered. It is a haunting thought, that the difference between our reality and a utopian future was a single man's choice, made in a moment of profound, terrifying clarity. If you want to explore more stories of small causes and global consequences, make sure to like this video and subscribe to the channel. We are constantly uncovering the hidden moments.